Okay, I'm going to answer questions 6 and 8 from the in-class work. First of all, question 6, you're asked to find the value of an expression. We've got ln, the natural logarithm. The first thing to do is to work from the inside out. Notice what's in brackets. So the first operation is, you see you've got a 1.0325 to the power of negative 1. So this is exponentiation. So what we do is to put 1 point, now follow along on your calculator, I'm going to do it 1.0325 to the 1 over x, or however your calculator says it, 1 over x, and I get here 0.96, and then it says 852, da da da. So I'm just going to round it up to 0.969. So that's the first bit. That is 1.0325 to the negative 1. So that is in effect 1 over 1.0325. That's the first step. The second step, we're still within these brackets. You see there's two sets of brackets. The next step is to multiply it by 4,000. So times 4,000 and times 4,000, and I get 3.87. 3.874. So that's the value of this whole expression within those square brackets is 3.874. The final step is to take the ln, the natural logarithm. So we will ln of 3.874. So you just press the ln key on your calculator and it comes out to 8.262. So that's the working for this question, and you can see from that that B would be the correct answer to this question. Okay, now this question, this is the next question, question 8. We have three people who have set up a partnership. Let's call them J, S, and M for short. So each of them has contributed some money to the partnership, but the amount that they've contributed, we don't know what it is. But what we do know is that the total of it is 315,000. So let's just call them J, S, and M. So call J, the money from J, plus the money from S, plus the money from M, we know adds up to $315,000. So that's one equation. Now we also know some other relationships. We know that Sue's contribution is 1/2 of Jim's. So I could write the contribution from Sue equals, it doesn't equal J, it equals J divided by 2, 1/2 of Jim. So let's say that Sue gave $10, and Jim gave 20, that would be the same thing, isn't it? 10 equals 20 over 2. The third one is that Marion's contribution is 2 times Jim's contribution. So now I can write M equals 2 times whatever it is that J gave. So that's the beauty of this algebra, is we don't need to know the actual number. We just have some letter which stands in for that. Now, you notice here in this first equation, I've got it in terms of J and S and M. Here, I've got two further equations, which are S and M in terms of J. So that means that I can substitute S and M, because here's S, here's S. So S equals J over 2. Now, the first J goes in here, That's this j here, goes in. I'm rewriting the first equation in terms of what I now know. So there's our first j. Now s here, s equals j over 2. So instead of writing s, I can write j divided by 2. It's the same thing. We don't know what it is, but it means the same thing. The third one is m here. Now m equals j over 2. So instead of writing m, I can write 2j. 2j. So I've just replaced those terms all in terms of j. I need only one unknown. We call it an unknown. Now that still equals 315,000. There's no change on the right. It still equals 315,000. Okay, now I've got something I can work with. So I can substitute these terms. I've got 1j, half a j, and 3 j's. So added together, that's 3 and 1/2 j. That's 3, not 31. I'm going to make a space there. It doesn't look too good. So 3.5j equals 315,000. So divide both sides by 3.5. So j equals 315,000 divided by, I'll write it as 3.5, make it clear. And if you divide 315,000 divide by 3.5 comes to 90,000. So therefore, you see, here's the answer. And that means that A is correct from the selection of answers. So the trick is to get things in terms of one unknown so that you can solve the equation. Just rewrite it. Just think of the different relationships. Good. Thank you.